Hello everyone, welcome to the lecture 6 of course Climate Change and Extreme Events. In the past two lectures in this week, we had discussed about what is exactly temperature extremes. We have discussed about what is exactly heat waves, then we have talked about cold waves, cold spells and different types of their mechanism and all. Then after that we have talked about precipitation extremes. What is exactly extreme precipitation events, how we can classify them. Then we have also discussed about different types of the thresholds where we can classify the extreme rainfall events based on certain values. Then after that we had discussed about the hydrological extremes which are linked to extreme precipitation events. For example, we talked about floods, different types of floods, how changes in the warming scenarios are amplifying the floods occurrences. Then we have also talked about what is exactly drought, how many types of drought can occur in a one particular place, and then how the climate change effects propagates or amplifies the effect of drought at a certain place in a different parts of the world. So all these things we have already covered in the past two lectures. In today's lecture, we will primarily talk about what is exactly extreme weather events, which is tropical cyclones, storms and their associated extreme weather events, which basically also very important to understand, because when these tropical cyclones or storms or similar events occurs in a particular place, that also creates a significant damage to the socio-economical conditions as well as disrupt the livelihood biodiversity of those particular regions as well. So in this particular lecture we will first go through what is exactly tropical cyclone, then we will also discuss about different types of tropical cyclones, their governing mechanism, which area these tropical cyclones are more forms or where the occurrences are very high, and we will also talk about what is the historical projections of tropical cyclones and what will happen if the greenhouse gases will keep on rising, and that will basically increase the temperature, or in a other way if it is global warming, then how these tropical cyclones will impact different parts of the world, whether is their occurrences are likely to be increased or decreased or more or less same like that. So this is the whole things we will, and towards the end of the lecture we will also discuss about what is exactly different types of impacts which are created by these types of extreme weather events like that. So starting with, first we need to understand what is exactly tropical cyclone. So as the term suggests, tropical, which means these types of large weather events or extreme weather events occurs near the tropics of where we have tropical regions in the lower latitude region of in the earth. So tropical cyclones can be defined as an intense low pressure system that form over warm tropical oceans. So particularly those ocean system which are located near to the tropics, and there the tropical cyclone formation possibilities or probabilities are very high. So these types of extreme weather events are powered by the heat and moisture of the ocean surface, and it is basically developed when the sea surface temperature exceeds approximately more than 26 or 26 degrees centigrade like that. So a certain types of temperature is required to form a tropical cyclone in those types of areas, tropical region, where we have a sufficient amount of moisture as well as the temperature differences that can create a sort of low pressure region there, and where the winds will speeds are very high, and that forms some sort of extreme weather phenomena there. Sometimes These tropical cyclones can also be referred as hurricane, typhoon. It depends upon their nomenclature, depends upon where they are occurring or where they are located. In the later part of this slide, we will also discuss about in what part of the world what we call exactly, what is a specific name of, let us say, tropical cyclone or something else there. So, when you talk about tropical cyclone, this is also has some certain defined structures. So, for example, there is a Areal region where we have a very strong winds and heavy rainfall events occurs in those particular region. Then we have also in the tropical cyclone, there is a region called rain bands, which is the outer areas of the tropical cyclone, where we also have a very significant amount of rainfall and strong winds and the outer part of the tropical cyclones. So, in conclusion, we can say that there are three major areas in the tropical cyclone in the structure. One is called eye, which is the center part of tropical cyclone. The second is basically the inner circle, which is called eye wall, and then we have outer circle, which is called rain bands. So, in the center part of the region, we have calm winds like that. In the inner circle, we have relatively higher wind velocities and extreme precipitation events like that. And the outer region also we have very strong winds as well as a very high heavy rainfall, heavy downpour in those particular regions as well. So, in the central part of the tropical cyclone region is a, as we discussed, is a calm area where we can see a clear area of sinking area air with light winds, usually rotates or basically moves around 15 miles per hour, that is the speed. And then we have also you can convert into 24 kilometer per hour speed like that. And this particular region I is largely 20 to 40 miles in radius, or maybe if you convert into kilometer, this is like 32 to 64 kilometers approximately like that. Then in the inner circle, which is we call eye wall, which is we have a ring of tall thunderstorms that produce very heavy rainfall and usually strongest wind in this particular region. And then the outer area of the cyclone is called spiral bands clouds, which is called rain bands, and that also brings a very heavy rainfall, strong winds and tornadoes or some sort of extreme weather phenomena in those regions like that. So, when you started with, I just discussed that the tropical cyclones are forms very close to the tropics or tropical regions are located, or lower latitude regions very close to the tropical region. Because of the optimum temperature of 26 degree which is there, which is very favorable conditions to form the cyclones in those regions like that. So, generally the tropical cyclones from the near the equator forms, and this is basically when the temperature is around 26 or 27 degree, but it is rarely develops within the 5 degree latitude. If you just draw 5 degree latitude here and here from 0 degree latitude line. So, it is very rare phenomena where it occurs, and this is largely because of there is a lack of sufficient Coriolis force there, and that is basically important factor to basically fuels the tropical cyclone in those regions like that. So, therefore, most of the regions which are near to the tropics, for example, if you look at Indian Ocean here, there are several part of region here as well, and or if you go a little bit down near to the Africa and in between Australia also, or if you look at here near to the North American region and this part of the western part of the North American region as well. So, here we can see there is a significant chances of formation of tropical cyclones, and in these different regions these tropical cyclones are called a very different name like typhoon, or somewhere it is called like tornadoes, or some like different types of nomenclature we say that. So, how it forms basically tropical cyclones? So, generally when the temperature reaches an optimum temperature, warm ocean that fuels the tropical cyclones because of the temperature difference. Because of the higher warming of ocean surface, the water vapor rises, conversion of water to vapor, and then vapor escapes to the atmosphere and condensing it to the clouds and release the heats in the upper part of the atmosphere. That basically the release of the heat air causing it to the rise and draw in surface air, generating strong winds across that particular region, because the warm air basically keep rising, and to the place where the warm air was, the cold air was now filling up that spaces, and because of this process the velocity of air increases, or strong winds increases, and therefore that creates more dynamic nature, or more um, uh, some sort of very disturbances in that particular regions like that. Once this storm eye is formed and it moves towards the land, generally it weakens, because when the storms or tropical cyclone moves toward the land part of the area, it basically loses the heat plus the moisture source. Therefore, in the land, when it is enters into the land, it basically restricted to some region, and then is basically weakens after that. So, this is one of the graphical representation of how what we have just discussed here. It is basically showing here that this is basically a warm air, and then it is converting to water vapor, and then water vapor contains at the troposphere and basically releases the heat, then making it air lighter, and therefore this area where this air was there, it basically replaced by another cold masses, and therefore it is creating some sort of turbulences in these areas like that. Sometimes it is also important to understand that only the warm water is not alone enough to create a tropical cyclone or a tropical storm or different types of weather extreme phenomena there in the oceanic body. There are several other large atmospheric phenomena which are also responsible to create or to fuel or to basically enhance the effect of a tropical cyclone or formation of the tropical cyclone in certain regions. For example, there is a one particular phenomena is called easterly waves. That is very important because it is creating the low pressure moving westwards in the tropics, and most tropical cyclones starts this way because of the easterly wave effect. Then we have West African disturbances line, that is called WADL. This line basically their storm is forming over the Western Africa and moves toward the Atlantic, and then these types of cyclonic disturbances or the disturbances are faster than whatever the tropical cyclone generated with the easterly waves. Then you have another type of atmospheric disturbance called TUTT, which is tropical upper tropospheric trough. This is the cool area in the upper atmosphere that can lead to storm formation, and therefore sometimes these turn into the tropical cyclones. And there is another phenomena like old frontal boundaries, where we have leftover cold fronts that can create storms, especially in the those regions like Gulf of Mexico, Caribbean, and all these regions where predominantly at the start and end of the hurricane seasons like that. So, therefore, these are the four different phenomena which is also responsible to initiate or to propagate the effect of tropical cyclone in certain region. It is not necessary that if you have 26° or 27° temperature at certain place in a ocean, you will have a cyclonic condition, but you need more catalyst to form that kind of tropical cyclone conditions in those regions like that. This is a graphical representation of how the tropical cyclones actually covers the larger area like that. So, there is comparison of two different tropical cyclone, which is called typhoon here and then tropical storm here. So, if you look at the super typhoon tip event, which occurred in 1979, and it has the area is covering 675 miles or approximately 690 miles, and that is basically a very large area it has been covered by this particular typhoon events, and also suffered basically impacted the significant region across the USA, or not exactly USA, but other part of the world. Here I have taken the USA as an example, which can tell you about what is the total area was covered by this particular cyclone event. There is a smallest storm which is called Marco, which has happened in 2008, and the area and the radius was around 11.5 miles, and it is basically hits the Mexico region, and during 2008, like that. So it was a very small, it was a very large event. Now you can understand there are variety of tropical cyclones with their geographical coverage can exist and can occur in different parts of the world, and can basically affect a large area as well as a shorter or smaller area as well. This is the table which tells you about the different classification of the cyclones across different parts of the world, particularly those regions, oceans. For example, if you talk about Southwest Indian Ocean, then you can talk about, let's say, Arabian Sea, Bay of Bengal, and then you can talk about Northwest Pacific, North Atlantic, Northeast Pacific region, or Southwest Pacific and Southeast Indian Ocean, like that. So we have divided different water bodies, ocean bodies into 5 different classifications, and based on that we are classifying the name of the cyclones which has been occurring in these particular regions, like that. So in this particular column here, it shows that the speed of wind speed of these cyclones across different areas. Knot is a measurement unit which is generally used to measure the how much distance it is covered by one particular ship, or in an ocean region where we are covering the length based on, or basically speed based on knot or nautical miles, like that. Then we have another unit which is kilometer per hour, and then we have Beaufort, also another unit which basically used for speed measurement of cyclones as well. So based on different speed threshold, we distribute the different types of cyclone event in their different types of names, like that. For example, if we talk about only the tropical disturbances or depression, or let us say some sort of low tropical depressions, like that. So speed are generally less than 50 kilometer per hour. Once it crosses the speed, let us say more than 50 kilometer per hour, that is called also the tropical depressions, but in different velocity criteria, like that. But once it is crosses the let us say threshold 62 kilometer per hour, and it is become like 63 kilometer per hour, like that. So in this case, this tropical cyclones can be named as moderate tropical storms or cyclonic storm, or let us say somewhere it is called tropical storms or tropical cyclone category 1 or category 2, like that. Once it is crosses the 89 or 90 kilometer per hour threshold, this tropical storms can be also named as severe tropical storms or severe tropical severe cyclonic storms, like that. Once it is crosses, let us say 117 kilometer per hour threshold, there are several types of names which are pronounced in different parts of the world. For example, in the Southwest Indian Ocean, it is called tropical cyclone. In the Arabian Sea and Bay of Bengal region, it is called very severe cyclonic storm. In the Northwest Pacific region, it is called more than threshold 118 kilometer per hour is called typhoon. And in the North Atlantic and Northeast Pacific region, it is called hurricane cat 1 category 1, hurricane category 2, category 3, category 4 and category 5, like that, based on different types of velocity thresholds, for example. So here it is written this is up to 118 to 153, then 154 to 177, 178 to 208. Similarly, more than 251 is categorized as hurricane category 5 event. Similarly, in the Southwest Pacific and Southeast Indian Ocean, we can call different types of cyclonic events. For example, tropical cyclone category 3, category 4 and category 5. And then in the Northwest Pacific, as we just discussed, it is completely is called typhoon event, like that. So, it depends upon the location where this phenomena is observing, and then based on that location and based on the speed criteria, the wind velocities, wind speeds in that particular region can be a factor which can give us to name a certain types of tropical cyclones in different parts of the world, like that. So, I have taken these classification system from World Meteorological Organization. One can also look at their classifications as well. Okay, so far this is all about tropical cyclone, what is exactly how they are forming, let us say what is their structure of the tropical cyclones, different types of atmospheric phenomena which fuels tropical cyclones. Then we have also talked about what is the different category of tropical cyclones, which is a nomenclature where we different types of tropical cyclones called in different parts of the world, like that. So, there are latest studies which has been also observing there is an increased occurrences of cyclone events or tropical cyclone events across the world. For example, here this map shows that those tropical cyclones which has the velocity is 45 kT knot 24 hour, and this is 30 kT in 24 hours, like that. If you look at this particular picture, it shows that yearly changes in the occurrences of these phenomena across historical time period since 1980s to 2020 almost. So, here it shows that most of the tropical regions are in the red zone, which suggests that most of these tropical cyclones are increasing in nature. There are few instances where we have also observed that there is a decreasing pattern, and there is some black dots also observed here, which is basically suggesting that these trends are statistically significant. Similarly, if you talk about lower velocity speed of wind, these tropical cyclones across the world, we have also observed there is a significant rise in the tropical cyclones across different part of the world, particularly this particular region where we have observed a very significant rise, and these changes in the tropical cyclone frequencies are also statistically significant, which means with the use of the data set we say that okay, if there is a trend that is statistically significant up to the confidence interval 0.05, like that. This is the another linear plot where it tells about the frequencies of different events which is occurring near to within 400 kilometer to the coast, and number of events like that, or so it tells you about it is continuously increasing in the nature. If you talk about there are certain events which are also close to different, that is also suggesting that there is a change in the increasing pattern of these cyclonic events across globally and for different velocity categories also. So, this historical development or historical analysis tells you a very clear message that tropical cyclones are frequently occurring near the tropical region, and these trends are continuously increasing, which we have already seen using the historical data sets, like that. This is the one example which tells about what is the impact of global warming on the cyclones. For example, tropical cyclone, extratropical cyclones and atmospheric rivers. So, if you talk about the whole globe, average and maximum precipitation rates increases with warming, particularly the tropical region where the tropical cyclones are more common. these tropical cyclone strength is increases, and there are certain places where we have also observed there is a decrement or decreasing magnitude of or frequencies of these cyclonic events in those regions, and there are some regions which are unchanged as well. There are some regions which is called extratropical, which is higher latitude, or let us say this particular region and this particular region, like that, where increases and decreases both are occurring. But and also there are some regions where we have observed there is a poleward shifts in the tropical cyclones in those regions as well. So, this is a very summary plot of these global warming of cyclones, which tells which nicely explains that the regions where we have observed that there is a decrease in exposure of the tropical cyclones, and there is a region where we have also observed there is an increase in the frequencies of tropical cyclones in those regions, like that. For example, this particular region we have also observed in the historical time period as well. In the warming period, it is also suggesting that there is an increased exposure of the tropical cyclone occurrence in these particular regions as well. There are certain regions near to the US coast where we have observed that the tropical cyclones are likely to be slow motion and also for the longer seasons, like that. So, this is all about what is exactly we have observed through the historical records and what is likely to be the condition for if the continuous warming across the world because of the greenhouse gas emission, and what would happen if the greenhouse gas emission are continuously rising and therefore increasing the global temperature. What would be the situation of, let us say, tropical cyclones are near to the different parts of the global regions, like that. Then another important question comes, what is exactly impact of cyclones? How these cyclonic events or extreme weather phenomena are impacting the socioeconomic conditions, or let us say biodiversity, human life, or several different factors, like that. So, I have just written few of very important impacts which is caused by cyclones. For example, human life and safety. Because of the cyclones, we have already read multiple newspapers or multiple newses from different sources that the loss of life due to strong winds, floodings and storm surges cause significant damages. There is a displacement of communities because of resettlement or rehabilitation of those areas because of the damages caused by these tropical cyclones in several parts of the regions. In India also, for example, we talk about several tropical cyclones which occur near the Odisha coast, where these phenomena are very common. Then we have also observed there is a infrastructural damages because of these tropical cyclones that damages homes, buildings and critical infrastructure, for example, roads, bridges, power lines, and to build them again we need extra time, extra funds, extra money to basically that which basically sometimes affect the overall economical conditions or social conditions of that particular regions, like that. It also damages the communication networks, basically the wireless network or the emergency response efforts. Those are very lifeline. When these infrastructures are damaged, we are not able to convey our message from one place to another place, and therefore that is basically affect the overall response efforts during that cyclone events, like that. As we have discussed that economic losses because of multiple infrastructures or crop or let us say there are several types of businesses, for example, fisheries, small businesses are affected by these tropical cyclones, disruptions of industries, trade, economic instability or of these regions. There is an increased cost of disaster response because and rebuilding efforts that also require some sort of money. Therefore, that significantly affect the economical status of that particular regions, like that. Then there is an environmental impact, which is basically the coastal erosion and destruction of ecosystem like mangroves, coral reefs and contamination of fresh water supplies due to salt water intrusion. That is one of very significant impact which we have already seen because of the different cyclone events near to the coastal region, and that is basically a very significant challenge to sometimes manage those efforts like that. So, this is overall the impact of cyclones which is creating different parts of the world, also in Indian region, and it is very important to understand that how these cyclone events are forming, what is their likelihood conditions for future, and what has happened in the historical period, so that we can have a better preparedness or early warning system, so that we can deploy those areas where these events are more common and frequently occurring like that. So, this is the total what I would like to teach you about extreme weather events, particularly tropical cyclone, storm, and these weather phenomena. In the next lecture, we will primarily summarize what we have so far covered in the week 2, and then we will discuss about the second assignment of week 2, and then later on in the next class we will also discuss about how we can solve this assignment 2 using some sort of different types of data sets as well. Thank you so much for your attention.